name is on this slide. When we ran our first North Bay Python, our headline speaker for today lived in the greater North Bay. And then, as we were planning to invite him to headline last year's North Bay Python, he decided that he was going to go walk the length of the West Coast. Happily, he is here with us this year, and is going to be presenting to us a bit about authentication.
That's right.
Please make welcome JacobKaplan-Moss.
Thanks, Chris. Morning, folks. Is my mic on? There we go. All right. So you've probably seen this. I helped make it. I'm here to convince you not to do that. Yes, the irony is not lost on me, but here's the thing. A decade ago, almost 15 years ago, this seemed like an appropriate way to do authentication. My argument today is basically that it's not anymore. This is no longer how you should be thinking about authentication if you're building 99% of web apps. There's going to be someone here works for Microsoft, I'm sure. You can do user authentication. This talk's not for you. This talk's for everyone else but Steve. So an interesting thing happened when I wrote this talk. I knew where I wanted to get to, and I knew the argument I wanted to make. And when I started trying to make that argument to friends, to colleagues, most people didn't believe me. Most people thought I was wrong. I got a lot of arguments and pushback. So I ended up having to take a pretty long detour into the type of thinking that a security professional might go through to get to this. And so that's what actually the bulk of this talk is going to be about. We're going to come back to why you shouldn't use passwords towards the end of this talk. We're going to take a long detour through threat modeling, and we're going to use it to look at password systems and authentication systems and the types of problems that come up and a bit about the history of those systems. And that's fine because I love threat modeling, and so this ended up being a sneaky way of teaching something different than I expected to talk about. But that's fine. All right, so let's talk about threat modeling. So you may have heard this term before. Security people like to talk about it. I haven't been able to come up with a really concise definition of threat modeling. The best thing that I could come up with, I tweeted this a couple days ago, is that threat modeling is improv for security architecture. Threat modeling is just a name for sitting down with your colleagues and trying to figure out what could go wrong before it goes wrong. And there's a whole variety of techniques for threat modeling, from some very, very formal techniques that involve architecture diagrams and formal analysis and a lot of interesting work, to like some super informal stuff. And I'm going to teach you a very informal system that I think gets 80–90% of the results with 10% of the effort. Unfortunately, the seminal text on threat modeling is written by a security person with a long history of abuse in the security community, and so I can't recommend his work. There isn't a great source of information if you want to dig deeper. And I'm sorry about that, and hopefully one of these days someone will do something about that. But in the absence of a great text to recommend, here's something you can do that's super practical and pretty easy and can be covered in under an hour. So the idea is scenario-based threat modeling. Basically, tell a story. Imagine a breach has happened. Take that breach from the news. Take it from data on security breaches in history. Take it from your last penetration test. Take it from rolling some dice, whatever. Tell a story about a breach. Imagine it's happened. And then conduct a pre-mortem. Do the type of analysis you would do after a post-mortem. 5 whys, infinite hows, whatever technique you like to use. And deconstruct that breach into the contributing events, and then figure out how to mitigate those events. This is exactly what you do after a real security breach, except you do it beforehand, and then you make some choices about what to mitigate and how to mitigate. Let me give you an example before we start talking about authentication systems. There's a Twitter account. It's run by Ryan McGeehan at Magoo, who's a long-time security engineer, has worked for Facebook, helped with the early architecture of Coinbase, long resume. Bad Things Daily is great. He tweets tabletop scenarios, imagine breach scenarios. This is a great place to get ideas for scenarios. So let's imagine your CI server has been compromised. The attacker has stolen all of your build variables. All right, so let's conduct a premortem. What might have been the contributing factors here? What might be the problems that would arise because of this event? Yeah, just shout it out.
Credentials are linked to the attacker, and then they can impersonate that particular account or authentication to do whatever they like.
Right, so some of the credentials that are on the CI server, the attacker now has them and can use them to do whatever. A common thing that CI servers do, especially CD servers, continuous deployment, is to push to production. So maybe the CD server had AWS keys, and now the attacker can spin up new resources, can mine bitcoins, can download all your S3 buckets. What else? I saw a hand over here. They can break your tests. I don't know about you, but I don't need any help with that. What else? Malicious code, right? They've got access to your build servers, so they could insert malicious code into your deployment pipeline. Okay, so you get the idea. This would be the type of exercise you would do with your team. I could go deeper if I had a specific system in mind. Then the next step is to go through each of those issues and determine a mitigation here. You'll see that I'm using a bit of a mitigation framework here. I had to cut that for time, but find me during the weekend and we'll talk about it because I think it's interesting. Basically, you go through each of your examples. So, all right, we have overscoped AWS keys, and you determine how and in what way you want to mitigate that. Maybe we don't have a lot of time to put into this, and we don't think this is a super likely attack, so we're just going to make sure that we log it if it happens. We'll turn on CloudTrail. We'll look at it from time to time. Maybe we want to make sure that even if we do get breached, we contain that breach as much as possible, so we'll look into scoped IAM roles. Maybe we want to completely eliminate it, and so we'll switch to pull-based deploys where our production servers pull from the CI server, so we no longer need those credentials in the first place, et cetera. The details don't matter a whole lot for this talk. But this is threat modeling. You come up with a threat, you think about what could happen, what went into that, and then you come up with a to-do list, with a set of things to work on. Like I said, there are significantly more formal techniques you can look into, but this is the root of it, and this will get you a huge results. All right, so let's apply this to our login box. Let's use this technique on threat modeling, and let's think about how this applies to username and passwords. A little bit of history before we get into this, just to sort of set the stage. Like, why this? Why a username and a password? Like, why do we use this to authenticate with the vast majority of systems around the world? I never really thought about that before I started writing this talk. Like, why do we need two pieces of information? We have this one piece, a username, which is human readable. We have another piece, a password, which is supposed to be kept secret. Like, how did we get here? Well, the reason is computers started as single-user systems. There was no authentication. You turned the computer on. It was like a typewriter. You turned it on and you used it. We don't log into typewriters. We just use them. But early computers were terrifically expensive. Computing time was terrifically expensive. And at MIT in the 1960s, they invented the first multi-user operating system called the compatible time-sharing system. I don't know much about this. But the idea was, look, we've got multiple people using the same system. They've got to pay for access to this computer because it's terrifically expensive for the university to maintain. They don't want me to be using some other researcher's computing time. So we need two things. We need somewhere to store my data. And we could put that in some directory. Let's call it home/Jacob. And keep that separate from home/Russ, where Russ keeps his data. So we need a human readable token to identify who I am and where my stuff is. And then we need a secret so that Russ can't log in and steal my research. So we give myself a password. So this goes back over 50 years at this point, and we've kind of kept it with us. We've just kept doing this without really thinking about what has changed. But here's the thing, like in between the 1960s and now, the internet happened. And as has been well established, the internet ruined everything. So before we start talking about the internet, let's talk about the attacks that have cropped up against passwords, let's say pre-95-ish, pre-2000. Let's look at some classic attacks against passwords before we really get into what's going on the web at large now. So a really common thing that people used to worry about was shoulder surfing. So Jack is a disgruntled employee. He watches our CEO, Alberta, log in and remembers her password. 12345. She uses the same password that she used on her luggage. A lot of people like Spaceballs here. I was curious to see how many people would get that reference. Right. So now Jack has Alberta's password. He can now log in and use her password to embezzle funds. So let's decompose this. Let's think about some of the things that happened after or that led up to that. So when he looked over her shoulder, he could see her password. So a really common thing that people started doing early on was masking passwords. You've seen this. When you type your password, you don't see anything on the screen, or you see little dots show up. Another thing that people started doing early on was password complexity, right? Your password must be 10 characters long and contain an exclamation point or a period and numbers and uppercase letters, all of those rules. Another issue that contributed to this is that Jack can use Alberta's password at a time remove. This is actually an important factor when thinking about security vulnerabilities. Temporality is important in that if I'm patient as an attacker, no one can detect when the attack happened, right? I don't know that anything's wrong. As a defender, I don't know that anything's wrong until Jack uses that password days or weeks or even months later. And that's a problem for preventing attacks and for forensics and for understanding what happened. Ideally, we'd like an opportunity to catch someone when they're doing something rather than having to piece together what happened later. So we could contain this through password rotation, right? We could force everyone to change their passwords every few months. That's where the whole idea came from, right? Because passwords can be used later, so let's force people to change their passwords. Password complexity will help to some degree here. Again, we can completely eliminate this reuse threat with two-factor authentication by requiring a code from a phone or a text message or a press on a YubiKey, et cetera. We'll talk about the effectiveness of these mitigations a little bit later, but a thing that you might want to start thinking about is how many of these are actually effective. Put that in the back of your mind. These are the mitigations that we've been using for decades, but do they actually work? All right, so let's talk about another attack, password leaks. So ping is a command line tool that pings another server on the internet, lets you, it's used to diagnose how your internet connection is working most of the time. And because of all sorts of badness in Unix, ping has to run as root. It has to run as a privileged user because of terrible, terrible reasons. Is this still true? Has it been fixed yet? It's still true. Oh my goodness. So what that means is that if there was a vulnerability in ping, an unprivileged user could use ping to read, say, Etsy password. And yes, I'm aware that real systems don't store passwords in Etsy password. I'm simplifying. But back in the day, we worried about this a lot. We had multi-user systems. We didn't necessarily trust to have the same user on the same, we didn't trust that all of the users on the same system were necessarily well-behaved. And so vulnerabilities in programs like ping were a big deal because they let an attacker read the password file. So what are some contributing factors to this? Right, so a big problem is that if Jack gets access to the password file, he can just read everyone's password. So the classic solution to this was to store using hashed passwords. A hash, A hash is just a one-way function. It takes the password and spits out a long string of gibberish in such a way that if you know the password, you can compute the hash very, very quickly, but if you know the hash, computing the password is significantly more difficult. Think of it like mixing paint. If you know the color you're trying to get to, it's pretty easy to dollop out some red and green and blue and mix it all together and get a color, but if you're only looking at a shade of brown, figuring out what colors went into that is significantly more difficult. The classic Unixy way of doing this was a program called crypt. Nowadays, you may hear about MD5 or SHA-1 or bcrypt or scrypt, whatever, hashed passwords. That goes hand in hand with password complexity. The more complex a password it is, the harder it is to break one of these hashes. So again, we need to ask users to use really strong passwords. Again, password rotation helps with the fact that Jack now has a database of everyone's passwords that he can use as a time remove. And again, multi-factor authentication eliminates much of this class of attack. Again, start thinking about how many of these mitigations are actually effective. So we have a bunch of different things we might do: masking input, complexity, rotation. Do these work? Let's take apart one of them. Let's talk a little bit about password rotation and think for a minute about whether password rotation is actually an effective security control. Put your hands up if you use a system that requires you to change your password on some regular basis. All right, keep your hands up if you think that that is positively contributing to the security of that system. Right, only a couple of people. So there's actually been research into this, and the discovery is that the vast majority of users can't remember their passwords when they have to change them regularly. So they do a few things. Either they continually have to reach out to the help desk to get their passwords reset, which introduces its own form of vulnerability, or more likely, they come up with a system to reuse the same password. So when they join, they use the password, the Petaluma as their password, the first. And then 3 months later, when they have to rotate, they use Petaluma 1. And then 3 months later, Petaluma 2. And then 3 months later, Petaluma 3. So as an attacker, how much security does this really add? Also, research has shown that people, when they know that rotation is required, they tend to use worse passwords. And this makes sense if you think about it, right? If you're required to change your password regularly, you want to use something you're going to remember. So when people are confronted with systems that don't require password rotation, they tend to use better passwords because they know that, yeah, this is long and complicated, but I only have to remember it once. But when confronted with a system that requires them to change it regularly, they downgrade the security of their passwords. And those of you, I'm not going to ask for a show of hands, but those of you who do use systems that require rotation, think about whether you use passwords for those systems that are stronger or weaker than your average password that you use somewhere else. So here's the thing. Anytime you have a security mechanism that relies on people to do something, you're just sort of like, it's like money laundering for risk. You're like putting it somewhere else and pretending it doesn't exist, but you haven't actually solved any problems. You've just created a situation where if you get breached, you can blame users instead of yourself. But that's not actually reducing any risk. The fact is that only effective security measures are systemic. And again, we can actually go way back. We can go all the way back to a book called The Design of Everyday Things by Donald Norman, which was written, I think, in the 60s. We've known this for decades, that when we attribute blame to human error, what we're really saying is poor design. We're saying the system is badly designed. Like humans make mistakes. It's what we do. It's part of our nature. Pinning the blame on the person may be comfortable, but why was the system ever designed in a way that a single person could cause calamity? The fact is that password complexity and rotation don't work, and there have been decades of research showing this to be true. The only form of password complexity that works is just sheer length. Make sure that people have very long passwords. All those bullshit rules about an underscore and 3 emojis and an astrological sign are completely meaningless. And in fact, even the federal government, the most risk-averse, organization known to man has actually figured this out. The latest version of the government's digital identity guidelines specifically say no composition rules and no password rotation. If you actually go in and read the appendix to this special publication, there's a very good discussion and citations to a lot of this research. If the federal government's policies are doing a better job for security than you are, whew. Look, I worked for the federal government for 3 years, and I wrote security systems there. So, I'm not pointing fingers anywhere but myself. So, OK, that was then. This is now. Let's talk about some modern attacks against password systems. So, phishing. So yesterday, your CEO got an email that looked like this. Hey, your admin needs to show some files, so Dropbox needs to know that it's you. So she clicked on the link, typed in her Dropbox credentials, downloaded some files, and went about her day. And this morning over coffee, she said, hey, I couldn't open that document you sent me yesterday. And her admin said, what document? So I've been phished. Most people have. I'm not going to ask for a show of hands because it's embarrassing to admit. There was an amazing thread on Twitter a few months ago of security professionals admitting their biggest mistakes. And the fact is that a good phishing attack is nearly impossible to detect. And let's think about some of the threats here. So the attacker now has access to Dropbox. So multi-factor authentication could help here if we were using MFA, if we were requiring MFA for our Dropbox accounts. This could have helped. Although, notice that I don't classify multi-factor authentication as an elimination threat. Most MFA systems, hardware keys being the exception, are fairly easy to phish. Not fairly easy, but could be phished by a dedicated attacker. I've seen situations where you attempt to log into a system and it triggers an SMS on another system, and so you get the SMS that you expect to get, and then it asks you to type the SMS in. There's some pretty complex phishing attacks here. There have also been instances of authenticator programs that run on your phone having malicious code that leak those authentication credentials to third parties. So MFA is not necessarily a protection against phishing. Your CEO probably used the same password for Dropbox as she used somewhere else. That's not because she's bad at being a CEO, but it's because CEOs are generally bad at operational security. A pretty sad rule of working in security organizations is the higher up someone is in the corporate hierarchy, generally the worse they are at practicing at good operational security. And again, that's not because they're dumb people. That's because we've built dumb systems. And your CEO couldn't tell the difference between the real site and Dropbox. It's nearly impossible just looking at a site to tell the difference between a real and a fake. There are some little things that give it away, but man, I've seen some really, really good ones. You may have seen U2F, Universal Second Factor, or WebAuthn. The whole reason behind the invention of these standards, the little blue keys originally, and now most YubiKeys, was that they contain information about the requesting site. They were specifically designed to prevent phishing, but that's really the only thing that can really prevent a phishing attack. And I want you to think. Don't think about yourself, because we're all sort of weird special cases, but think about the people you know in your life, your partners, your family, your children, your friends. How many of them use hardware keys? I'm guessing very, very few. Yeah. All right. The biggest attack that we have to deal with today is what's called credential stuffing. Credential stuffing is fairly simple. Password breaches happen all the time because of poor practices in the other areas we have here. And so what an attacker does is they take the passwords that they've stolen from one site and try them in another. So if you've signed up for, what is my example here? Vendatu. You used your email and you gave them a password. Well, now they have your email, which you probably used to log in to a bunch of other sites. And if you've reused that password anywhere else, now they can log into the other site using that password. The thing I want to point out here, notice the date on this tweet. This was 2 days ago. These breaches happen every couple of days. The size, I have like 1 billion passwords on my laptop right now. I probably have a password one of you used for some service just sitting on my laptop because I have weird hobbies. The main issue here is password reuse. So there's a bunch of things we could do about it. We could monitor have I been pwned for new breaches and download passwords and run them against our own accounts and see who's reused stuff and force them to invalidate. Some people do this. It's one of the reasons I have this password file. I do it, but it's pretty rare. Most security organizations aren't that good. We could require everyone to use password managers, but think about, not the people in the room, but your friends, your family, your partners, what have you. Do they use password managers? I'm guessing not. I talked to one of the original developers, the founding developers of a password manager, who admitted to me that their spouse does not use their product. Now, we could eliminate credential stuffing if we required 2FA, right? Because the password is useless if I don't also have the second factor. And we could also eliminate it if we use some sort of corporate single sign-on. Because that corporate single sign-on, it's very easy to just rotate passwords. We can monitor just that one place. We don't have to know all of the other places. So here's where we start to think about some of these common mitigations. Password managers, multi-factor auth, single sign-on. Are these mitigations effective? Well, they are, if they're actually used. But how many people actually use them? So Maciek Sigowski, who wrote Pinboard, wrote a long blog post about teaching congressional campaigns how to have good security practice. Now, these were Democratic campaigns, and he was trying to teach them how to keep their security safe. So if anyone is invested in this country, is invested in having good email security, you'd think it would be Democratic candidates after what happened to Hillary Clinton's campaign in 2016, and yet he still found a tremendous amount of resistance. Again, is that because these are dumb people? No, they're not. And it's because we've written dumb systems. Password managers simply remain too complicated, too complex, too error-prone. They're out of use for most normal people. Single sign-on is terrifically effective, but again, this typically only happens within corporate environments. And we could talk similar things about multi-factor hardware tokens, et cetera. So let's look at our summary of all the mitigations we've seen so far, right? Masked input is not effective. Shoulder surfing is really not a realistic attack anymore. Our screens have gotten very high resolution. We're typically working in offices where we don't worry about people looking over our shoulders anymore. Like, this was a concern in the mainframe era, but it's not really that much of a concern, and it decreases usability. If you have really long, complex passwords, but they're masked, now it's hard for people to log in. Password complexity is effective, but most people implement it wrong. Password rotation is just terrible. Hashed passwords, it gives you some time, but it's possible to crack hashed passwords even in the best of situations. Password managers are great, but most people don't use them. Multi-factor authentication is great, but a lot of people don't use them. Single sign-on is super effective, and people use it. The usability of single sign-on is great. If you've worked for an organization that uses something like Okta or Auth0, you know this. Like, your authentication story is you go to your portal and you click on Salesforce, and now you're in Salesforce. You go back, you click on Dropbox, and now you're logged into Dropbox. You click on Google, and now you're at your email. There's like you only have one username and password to remember. There's no multiple steps here. Super effective. So if U2F is more secure than passwords, why are we using passwords? Right? A system is only secure as its weakest link. So we've added a stronger link. Why are we still using the crappy link? And if U2F is giving us the security for our account, what's the password doing? And if single sign-on is more effective than spraying passwords everywhere, well, why are we using passwords? What if passwords are the problem? What if the actual problem with most of these systems are the passwords themselves? Well, let's go back to our threat models. What happens if we get rid of passwords? Is shoulder surfing an attack if the way I log in is by pressing my security key? I mean, you can see me do this. Oh no, you all saw me type my password. Are password leaks a problem? No, if you're not storing passwords, what do you have to leak? Is phishing a problem? No. If I don't type in my password to log into Dropbox, and Dropbox asks me for a password, I'm instantly going to know something's wrong. If I expect to get bounced to my single sign-on page, and I don't, great. Credential stuffing, again, if my security team only has one place to monitor, or if, on the flip side of it, if I'm an application developer and I don't even have passwords in my system, I don't have to worry about credential stuffing attacks. None of these are effective if users don't have passwords to steal. All right, so now we're finally back where we began, and I can start to talk about why, as an application developer, you probably don't want passwords. So here's the thing. By introducing passwords into your system, as you've seen, you've created a universe of problems for yourself. You have to figure out password complexity. You have to fight with the compliance department who wants you to do password rotation despite having read the NIST standards. You have to deal with implementing multi-factor authentication yourself. You have all of these mitigations that we've built up over the years, or you could just get rid of passwords entirely. So if not passwords, what else should we use, right? I'm not just going to give you a bunch of problems. There are some really good solutions here. So federated identity is great, right? You've probably seen these: log in with Facebook, log in with Google, log in with GitHub, et cetera. Email-only login. You may have seen this if you use Slack, right? You type in your email, it sends you a link, you click on the link, now you're logged in, no password. And of course, if you're in the business space, corporate identity, SAML, OpenID Connect. So federated identity is really great for consumer-oriented identity systems. Most people have a Google or a Facebook or a Spotify or whatever. These are especially good when you're using it in concert with a system that what has more to do with whatever your backing identity system is. So, let's say you're building an app in the health and fitness space. Having a Strava login is great because your target audience is mostly going to have Strava. You're going to be linking with Strava to be doing, whatever it is your application is building. So you're going to have to authenticate against Strava's API anyway. So why not just use that as your main authentication source? The UX is generally really good for these. Users are pretty used to them at this point. They're familiar with Facebook. They know how its authentication works, et cetera. Beware of the huge menu of login buttons. Studies have shown once you get to more than 2 or 3, people start to forget which system they used the last time. So you should think carefully about which ones to log in. If you're building systems for developers, GitHub might be a good choice. If you're using systems for athletes, Strava. If you're using social network stuff, Facebook and Twitter, et cetera. This does force a trade-off between privacy and security, right? You're trusting, you're giving Google just a little bit more information than they had before. So if you're building something where there's significant privacy implications, you're building an application for, journalists in hostile countries, okay, maybe this isn't a good idea. But again, for most people in this room, you're probably not. You're probably building a payroll application or an inventory tracking system or logistics software, and none of that really applies. And leaking a little bit about the fact that I just logged in is probably a lot better than getting breached. There is an open standard here called IndieAuth. It probably won't catch on because neither did OpenID, and everything is terrible, but it would be great if it did. So email-only login is the type of thing that every time I advocate for it, it freaks people out. But it's actually just another instance of federated identity. You're just delegating your security to the person's email provider. The way email login works is you type your email, you get a link, you click on the link in the email, and now you're logged in. No password required. Traditional security folks really feel bad about this because email. In the old school world, the idea was that email is not secure, right? That's how we used to think about this, is that email isn't secure. But here's the thing. Google's security team's better than your security team. Maybe not you, Steve, but I already said this talk's not for you. and I'm not, this isn't a joke. Google and Facebook and Microsoft and, a few companies have really gobbled up 99% of the best security people on the planet, and the rest of us are left hiring the few people who escape from that black hole out into the rest of the world. So when you're dealing with a federated identity system as an application developer, really the way you should be thinking about this is, am I going to do a better job than whoever I'm delegating to, right? Don't think about, is email better than usernames and passwords, because that's not the trade-off you're making. The trade-off you're making is between my problem and Google's problem. And Google's a lot better funded than I am. If you're selling to companies, if you're a B2C business, you really need to support corporate identity. I won't, in wearing my work hat, I won't buy your product if I can't hook it up to my corporate single sign-on system. I just won't. It's just not worth my time. It doesn't matter if it's very good. It's not worth my time to do an in-depth security analysis of your authentication system when I can just ask you to use this. And as a user, again, if you've used something like Okta or Auth0 or whatever, you know that they're really nice. They're really easy to use. The UX is great, et cetera. If you're an application developer and you're in this market, there's two big standards you need to know about, SAML and OpenID Connect. You should do SAML first. Most people don't. The support for OIDC is a lot less widespread, and by implementing SAML, you'll integrate with the vast majority of these systems just fine. So please, stop using passwords. Don't use authentication written in your own apps. The alternatives are easy, and they're more secure. Only roll your own identity system if you know what you're doing. Thank you.